Hello students, in this video we'll study about finding the largest eigenvalue of a matrix by Rayleigh's power method. In the Rayleigh's power method, if given a matrix A, we'll choose an initial approximation from either of it is 1 0 0 transpose or it is 0 1 0 or it is 0 0 1 transpose or 1 1 1 depending on the dominant element in the matrix A. In this example, they have given us to find out what is the dominant eigenvalue and corresponding eigenvector of the matrix A with the elements 4, 1, minus 1, 2, 3, minus 1, minus 2, 1, 5 by taking initial approximation. Note that here in the problem already the initial approximation is given. Given with the initial approximation, we have to multiply this initial approximation with the matrix A and that we take it as the first iteration. So first iteration is given by A into x naught. Multiply the x naught, that is the initial approximation, with the A. It's a matrix multiplication, row into column. So here it is row and this is the column. So this, since it is 3 cross 3 matrix and here it is 3 cross 1 matrix. So the answer matrix will be a column matrix given with the elements 4, 2, minus 2. So this is the multiplication of A x naught. Now in this we have to find the numerically largest element as common. So here 4, 2, minus 2. Out of these three elements, 4 is the largest element. So we have to take 4 common. Write the remaining elements. So it will be 4 by 4, 2 by 4 and minus 2 by 4. So that is the matrix 1.5 minus of 0.5. So this is written as lambda 1 x1. So here the first approximation for lambda is 4 and the first approximation for the corresponding eigenvector is 1.5 and minus 0.5. For the second iteration, we multiply A with the x1. That is, here the matrix A is multiplied with 1.5 minus of 0.5. Multiply these two matrices, the answer matrix will be, so here with the row and the column, 1 into 4 into 1, 1 into 0.5 minus 1 into 0.5. If you add them all, it will be 5, 4 minus 4. Here the largest element is 5. So take 5 common and write the remaining elements here. That matrix will be 1, 4 by 5 will be 0.8 and this is minus 0.8 as it is the same element with the minus sign. Now this can be written as lambda 2 x2. Here 5 is the second approximation for the eigenvalue and x2 with 1.8 minus 0.8 is for the corresponding eigenvector. For the third iteration, we multiply A with the x2, that is 1.8 minus 0.8. So do the matrix multiplication. We get the column matrix as 5.6, 5.2 and minus 5.2. So here the largest element is 5.6. Divide all the elements of the matrix by 5.6. We'll get this as 1.9285 minus of 0.9285. So this is written as lambda 3 x3. So the third approximation for the eigenvalue is 5.6 and the corresponding vector is 1.9285 minus of 0.9285. For the fourth iteration, Multiply the matrix A with the x3. It is 1 minus 0.9285 minus of 0.9285. The matrix multiplication. The multiplication of these two matrices will get it as 5.8571, 5.7142 and 5.7142 with the minus sign. So here the largest element is 5.8571. Take that common. Write the matrix. It is 1.9756 minus of 0.9756. So this is written as lambda 4 into x4. So the fourth approximation for the eigenvalue is 5.8571 and the corresponding eigenvector is 1.9756 minus of 0.9756. So these iterations will continue till the values of eigenvalues converges to the exact eigenvalue. So since in this problem they have given you to carry out 6 iterations, we'll take the 2 more iterations. Multiply A with the x4, that is multiplying A with 1.9756 minus of 0.9756. The multiplication of these two matrices, the column matrix is given with 5.9712, 5.9024 minus of 5.9024. So the largest element here, the dominant element is 5.9712. Divide all the numbers by 5.9712. We'll get the matrix as 1.9918 and minus of 0.9918. So this is written as lambda 5 x5. So the fifth approximation for the eigenvalue is 5.9712 and the corresponding eigenvector is 1.9918 minus of 0.9918. So for the sixth iteration, multiply the matrix A with x5. It is the matrix multiplication 1.9918 minus of 0.9918. So this matrix multiplication will get it as 0.9512. It is 5.9836, 5.9672 minus of 5.9672. Take out the largest element common. The largest element is 5.9836 and the corresponding vector, it is given as 1.9972 and 0.9972 with the minus 9. So this is of the form lambda 6 x6. So after the sixth iteration, the dominant eigenvalue is 5.9836 and the eigenvector corresponding to this is equal to 1.9972 minus of 0.9972. It's a column matrix, so here I will write the transpose. Now in this method, one more point we need to remember is that when we are taking the largest element as common, we should go for numerically largest element as common. Suppose that we have the after the multiplication with a into that initial approximation for the eigenvector, we get it something like -8, 6 and 7. In this case, the numerically largest element will become 8. Even though it is with the minus sign, we have to take the plus 8 as the numerically largest element common and write this as -1, 6 by 8 and 7 by 8. So it is taking the numerically largest element common irrespective of its sign. The matrix multiplication also we can do it in the calculator as, so we can go for shift, then keep the calculator in the matrix mode, and then it is shift the key 4. So it will appear as dimensions. In that, enter the dimensions of A. Enter matrix, enter the dimensions and also enter the elements. Once the matrix A is entered, go for pressing AC. So repeat the same step for matrix B. Matrix B. Now to multiply these two matrices, we need to go for shift key 4. Now here, don't choose the dimensions, choose mat A. Put an into sign and then again go for shift key 4 and choose mat B. So the matrix A into B will appear. We can write the matrix multiplication directly. Take the largest element common, write the matrix B. Now for the next iteration, to get the next matrix, only change the mat B as the elements after taking common. So repeat the same steps till you get the required answer. And you can use the calculator ES 991 or MS 991. Thank you for watching.